The Megalodon was big, really big. Everyone knows that. But in 2026, new studies have shown that the Megalodon wasn't just an oversized shark. It was something way bigger. But despite all the insane action movies and the massive amounts of research that have gone into this one thick shark, there's two questions that scientists still don't fully understand. How did it get so big, and how big actually was it? Well, to understand how it was even possible for something like Megalodon to exist in the first place, let's compare it to the sharks that were still allowed to exist today. Most of the time, when we hear about insanely large or extreme animals, they turn out to be exaggerated, misidentified, or not actually classed as a real species. Megalodon wasn't a myth or a misclassification, though. It was actually a real, scientifically recognized shark that genuinely reached an extreme size. Let's take a look at the great white. It is the gold standard for a predatory shark, but even the largest ones rarely top 20 feet. It's built for high-speed bursts and calorie-dense kills, but its size is kept by a brutal biological reality. The larger you are, the more energy it takes to move. If a great white tried to grow to 50 feet, it would likely starve to death simply trying to find enough food to power its own swimming. The only sharks that have managed to bypass this size limit are the whale shark and the basking shark. These are the current giants of the ocean, reaching lengths of 40 feet or more. But they had to make a massive trade-off to get there. Instead of hunting, they became filter feeders. They don't waste energy on massive teeth, powerful jaws, or high-speed chases. They just drift through the water with their mouths open, collecting microscopic plankton. This is the same path whales took to reach extreme size. Stuff like plankton and small schooling prey let whales take in enormous amounts of energy without the cost of constant pursuit. So let's add a megalodon next to these sharks. Well, there isn't exactly much of a competition in size. Logically, we'd expect something this big to only be eating krill and plankton, but you don't evolve massive 7-inch teeth if your prey is half a millimeter. It was able to reach whale-level size without abandoning active predation, something almost nothing else in the ocean has ever managed to do. So how is this remotely possible? Well, it's likely not just one reason, but a very selective couple of factors that allowed a once-in-a-lifetime opportunity for a shark this big to even be possible. To start, in modern day, basically every single shark is cold-blooded, but megalodons were warm. Well, partially. Most sharks are at the mercy of the water around them. If the water is cold, their muscles are slow, and their digestion is even slower. They're stuck in a low-energy lifestyle. But Megalodon could keep its core temperature significantly higher than the surrounding ocean, which gave it a massive advantage. It could swim faster, hunt in colder depths, and digest food much quicker than any other shark. The great white is one of the few sharks left today that actually shares this exact same trait. But wait, if being warm-blooded is the secret to getting huge, then why is the great white still so, well, small? Well, being warm-blooded is expensive. It requires a constant, massive intake of energy just to keep the lights on. Great whites hunt fish or seals, which is still a lot different than things like plankton. Their prey is proportionally sized down for their size. But megalodons were massive, so they hunted something different, something also massive. To fuel a body that size, you can't just eat fish, and you definitely can't just eat plankton. The energy it would take to catch them would be more than the calories the food itself provides. The megalodon was forced into a high-stakes diet of one thing: whale fat. During the Miocene, the ocean was essentially a giant, slow-moving buffet. It was filled with small to medium-sized baleen whales and large seals that were packed with blubber. Blubber is the most energy-dense substance in the ocean, and for a megalodon, it was the only fuel efficient enough to keep its warm-blooded engine from stalling. But the megalodon wasn't exactly hunting these whales like a normal shark would. It would, well, completely brutalize them. Most sharks today, like the great white, use a bite and spit tactic. They wound the prey and wait for it to bleed out. But the Megalodon couldn't afford to wait. It used its 40,000 pounds of bite force to literally crush through the rib cages and vital organs of whales. It was designed to end the fight instantly, turning a living animal into a massive pile of calories as quickly as possible. Most animals usually kill their prey before, then soon after, eat it. But the Megalodon's eating was the killing. And this worked out pretty well, honestly. As long as the whales were plentiful and easy to catch, the Megalodon would remain on top. Okay, so the Meg was big and its prey was also big. But size alone doesn't actually explain why the Meg was so abnormal. We've seen giants all the time in history. Size alone isn't always a biological anomaly. Getting crazy mega big is a strategy that plenty of animals have used. It wasn't just take a great white and scale it up a bunch. To understand what I mean, we have to look at its bite. Most predators follow a predictable scaling law. As an animal gets bigger, its strength increases, which is to be expected, but eventually biology hits a wall. The muscles can only get so thick, and the bones can only take so much pressure before they snap. But Megalodon's jaw seems to have bypassed that wall entirely. Scientists have reconstructed the bite force of a Megalodon to be roughly 40,000 pounds per square inch. For comparison, the great white, the most feared predator in our modern ocean, has a bite force of around 4,000 pounds. Even the Tyrannosaurus rex, the undisputed king of land predators, only managed around 12,000 pounds. For its estimated body mass, scaling laws predicted the Meg's bite to be something closer to 20,000 pounds. So why become so violent? You're already outputting 20,000 pounds of force. Do you really need to evolve double that? Well, again, the Meg's hunting system was weird. At this sheer size, failure isn't really an option. You're already at the limits of physics itself. When you're a 60-foot predator hunting animals that weigh as much as you do, you don't get long chases or wasting energy on any hunt. It's either you kill or you don't. Megalodon wasn't really an anomaly in nature. It was more just simply a response to everything else, a response to specifically the era when whales were starting to take over the planet. Before this, whales were relatively small, but suddenly they began to diversify and expand. The ocean was becoming a high-calorie factory filled with early baleen whales that were evolving to be bigger, faster, and more insulated with thick layers of blubber. As whales grow in size to protect themselves and store more energy, the predators that ate them were forced to keep pace. You can't hunt a 20-ton whale with a 5-ton body, at least not if you want to win. Whales might only eat plankton, but if you piss one off, it's still going to smack you with its tail and crush your insides instantly. It doesn't really matter how sharp your teeth are. Oddly, you'd expect that if staying huge and hunting whales was such a high-stakes, energy-draining strategy, then Megalodon would be stuck in one specific corner of the ocean, just being the evolutionary balance for where these big whales were located. But it wasn't. It was everywhere. Fossilized teeth from Megalodon have been pulled out of the sediment in Australia, Europe, Africa, and the Americas. They've been found in shallow tropical bays and in deep, cold, temperate zones across every major ocean on the planet. This shouldn't have worked. For a 60-ton predator, moving across an entire ocean is a logistical nightmare. Each mile you swim burns a massive amount of calories, and most sharks are strictly limited by the temperature of the water around them. If a typical shark swims into water that's too cold, its muscles slow down and its digestion basically stops. They are prisoners of their environment. So what was it about their biology that forced them to ignore the boundaries to stop every other shark? It turns out, by being partially warm-blooded, it had what's called regional endothermia. The megalodon could keep its core muscles and its stomach significantly warmer than the surrounding sea. To find enough whales to fuel its 60-ton frame, it couldn't afford to be picky about where it hunted. If it wasn't constantly finding and killing whales, it would literally burn through its own energy reserves and starve to death. It was a biological gamble, and for millions of years, that gamble paid off. If you couldn't tell, for this animal to exist, it was contingent on many factors going right for it. There's not many ways evolution could pull off a monster shark unless all the conditions were in place, and you still have to solve the most dangerous problem in nature, making more of yourself. As a 60-ton shark, this is a biological nightmare. We found fossilized nurseries in places like Panama and Spain, which were filled with the teeth of juvenile megalodons. But when we look at the size of those teeth, the scale doesn't even seem real. A newborn megalodon was estimated to be about 6.5 feet long. That means on day one, a baby megalodon was already larger than a full-grown adult human and bigger than most sharks in the ocean today. But why was the megalodon forced to give birth to such massive offspring? It likely comes down to a brutal strategy called oophagy, or egg-eating. Like their modern relatives, the great whites, megalodon embryos would hunt and eat their own siblings inside the mother's womb. By the time the shark is actually born, it's already been trained to kill. And it's grown large enough that it doesn't immediately fall to the bottom of the food chain. In open, shallow coastal waters acted as a buffer, physically separating newborns from full-grown adults, including their parents, that would otherwise eat them on sight. Cannibalism amongst megalodons didn't stop at birth, it just moved into the open ocean. Life was all about just getting bigger. Once they passed a certain size threshold, the list of predators dropped off hard. So if 60 feet was good, why wasn't 200 feet better? Well, Megalodon ran into the wall of physics known as the square-cube law. When you double the size of an animal, you don't just double its weight. While its surface area, the stuff like its skin and muscle, quadruples, its volume and mass octuples. It gets 8 times heavier every time it doubles in length. This means that every extra foot of the Megalodon evolved was a massive biological tax. By the time it reached 60 feet, it was already pushing the absolute limit of what a shark's body could physically handle. Its mass would have increased so fast that its heart wouldn't have been strong enough to pump blood to its tail. Its skeleton, which is made of flexible cartilage and not solid bone, would have started to deform under the sheer weight of its own organs. Sharks can get really big, but they can't get big forever, and they definitely won't be growing to the size of cruise ships anytime soon. Also, the larger you are, the better you are at holding on to heat, which is usually a good thing, but at a certain size, you become too good at it. If the Megalodon had grown much larger, it wouldn't have been able to vent enough heat into the water to stay cool. It would cook its own internal organs just from the friction of its muscles moving through the sea. So Megalodon was all about getting big, and they basically reached the limit for what was possible with sharks. But when your entire life fully revolves around getting as big as possible, if being big stops being a good thing, then, well, your entire life crumbles apart too. Megalodon was built for one very specific purpose: killing small, slow, fatty whales in warm water. But as the Pliocene began, the world started to cool down, the ocean shifted, currents changed, and the buffet that Megalodon depended on started to disappear. Those small, easy-to-catch whales either went extinct or did something Megalodon couldn't handle. They moved. They evolved to be larger and faster, and they migrated towards the freezing, nutrient-rich polar waters. Now, remember, Megalodon was partially warm-blooded, but it wasn't a whale. It couldn't handle the extreme cold of the poles for long. And even if it could, The energy cost of swimming that far just to find a meal was becoming impossible. And for the first time in millions of years, megalodons had real competition. When things like early orcas arrived, they were barely a fraction of the megalodon's size, but they were smarter, faster, and most importantly, social. While a megalodon had to find a massive whale and kill it alone to stay alive, a pod of orcas could work together to take down prey and survive on much less. But here's the weirdest part. When Megalodon finally vanished, nothing took its place. Usually, when a dominant predator goes extinct, evolution immediately starts working on a replacement. When the dinosaurs died, mammals stepped up. When the massive marine reptiles disappeared, the sharks took over. But when the megalodon died out, the apex vacuum it left behind just stayed empty. There is no modern shark that fills the megalodon's niche. There is no 60-foot active predator roaming the open ocean today. In fact, the closest thing to the megalodon's niche today isn't a great white. It's actually the orcas. They fill the ecological role of controlling and taking down large predators, like also hunting larger whales. They just didn't do it by crushing them in a giant bite. They're much more strategic. Sharks can't be social because for 400 million years, evolution has pushed their brains to do only one thing: detect. They track blood and other movement, and they aren't necessarily dumb, but they are nowhere near as smart as things like orcas. Being social, like hunting in a coordinated pack, requires a completely different set of biological capabilities. You need to be able to communicate complex ideas, recognize individuals, and most importantly, trust that the guy swimming next to you isn't going to try and eat you. As I said, these sharks would literally eat their own kids. They definitely aren't going to be making any cool teams anytime soon. And while obviously I can't 100% confirm since I haven't explored every part of the ocean, it just doesn't make any remote sense at all. The deep sea is a complete desert, and there isn't enough calorie-dense food down there to fuel a cold-blooded 10-foot shark, let alone a 60-ton warm-blooded monster. The baleen whales it needs to survive are too fast, live in water that is too cold, and are too spread out. If a megalodon existed today, it would starve to death in a week. But I guess I'm okay with only great whites existing. I don't really need any more mythological horrors existing in the deep sea. Thank you.